Hello everyone, I am Reddy Purva and today I am going to give a brief presentation on optical amplifiers. So, what is an optical amplifier? An optical amplifier is a device in which amplifiers amplifies the optical signal directly without changing it to electrical signal. So, basically, light is amplified here. An optical amplifier may be thought of a laser without an optical cavity, or one in which feedback from the cavity is suppressed. So the reasons to use the optical amplifiers are mainly reliability, flexibility, wavelength division multiplexing, and low cost. So why we need optical amplifiers? Um, we can increase the transmission distance with the help of optical amplifiers by increasing the optical power coupled to the transmission fiber, or by compensating optical fiber losses, or by improving the receiver sensitivity. So basically, the main function of using optical amplifier is to increase the transmission distance, or to the distance uh, to where we can transmit, so that we can increase the transmission distance. So the second major function is of an optical amplifier is that optical signal, we can amplify the optical signal without converting it to electrical signals. So main ingredients are pump energy and amplification medium. So here we have the optical input and we have a pumping energy. So we have a amplification medium here and we have a pumping energy and we get a optical output. So main issues of amplifier design are optimization. So we can optimize the amplifier design by maximizing the efficiency, minimizing the noise figure, maximizing the gain, maximizing gain peak width, and we should also take care of the dynamic range and operation wavelength, and gain equalization is also necessary in the receiver and transmitter side, for the transmitter and receiver side, and control circuit is also necessary. Monitoring of amplifier performance is also necessary in order to have a proper amplifier design. So these are the basic types of uh, optical amplifiers. First one is erbium doped amplifier, then erbium doped waveguide amplifier, Raman amplifier, and semiconductor optical amplifier. So basically, in erbium doped amplifier, we have doped fiber amplifier. These are also called doped fiber amplifiers. Uh, these are amplifiers that uses doped optical fiber as gain medium to amplify the optical signal. They are related to fiber lasers. The signal to be amplified and a pump laser are multiplexed into the dope fiber, and the signal is amplified through interaction with the doping ions. The most common example is the erbium dope fiber amplifier. So the erbium, where the core of silica fiber is doped with the trivalent erbium ions and can be efficiently pumped with the laser at a wavelength of 980 nanometer or 1480 nanometer that exhibits 1515 nanometer region. So this is the basic block diagram of erbium doped amplifier. There is an input signal, there is an isolator, and this is a pump source. This is erbium doped fiber, and this is again an isolator, and we get the amplified optical output. So the next one is erbium doped waveguide amplifier. In erbium doped waveguide amplifier, we have an optical amplifier that uses waveguide to boost the optical signal. Amplification is achieved by stimulated emission of photons from dopant ions in the doped fiber. The pump laser excites ion into a higher energy from where they can decay via stimulating the emission of photon and the signal wavelength back to the lower energy level. The excited ions can also decay spontaneously or even through non-radiative processes involving interaction with photons of the glass matrix. So, for the manufacture of wave, waveguide amplifiers, the two most advanced methods used are ion extensions, sputtering. So, the next amplifier we have is Raman amplifier. So, Raman amplifier rely on intrinsic non-linearly in silica fiber. Variable wavelength amplification depends on pump wavelength. For example, pumping at 1500 nanometer produces a gain about 1560 to 1570 nanometer. RF can be used as standalone amplifier or as a distributed amplifier in conjunction with an EDF. So the next one is semiconductor optical laser, or these are called also laser amplifiers, SOA and SLA. These amplifiers have similar structure, um, but the anti-reflection design elements are at the end faces are different. So semiconductor amplifiers are typically made of 3-4 compounds semiconductors such as gallium arsenide, aluminum gallium arsenide, indium phosphate, indium gallium arsenide, or indium phosphate or indium gallium arsenide phosphate. Though any direct band gap semiconductors such as 2 to 4 could conceivably use, such as amplifiers are often used in telecommunication systems in the form of fiber pixel components operating at signal wavelengths between 0.85 micrometer to 1.6 micrometer, generating gains up to 30 dB. The semiconductor optical fiber is of small size and electrically pumped. It can be potentially less expensive than EDFA and can be integrated with semiconductor lasers, modulators, etc. However, the performance is still not comparable with EDFA. The SOA has higher noise, lower gain, moderate polarization, depends on higher nonlinearity with fast transient time. The main advantage of SOA is that all four types of nonlinear operation, that is cross gain modulation, cross phase modulation, wavelength conversion, and four-way mixing can be conducted. Furthermore, SOA can be run with low power laser. This originates from the short nanosecond or less upper state lifetime, so that the gain reacts rapidly to changes of pump of signal power, and changes of gain also causes phase changes which can distort the signal. This nonlinearity presents the most severe problem for optical communication applications. So the next type is traveling wave SLA. That traveling wave SLA is different from the SOA in a number of ways. The cavity is lengthened or doubled or tripled to allow enough room for sufficient gain. Since amplifier uses a single pass through the device that doesn't resonate like a laser. Devices whose cavities are long as 2 mm are available. The back facet is anti-reflection coated and pigtail to provide entry of the input light. The exit facet of the amplifier is just the same of the laser except that it is also anti-reflection coated. Because of the absence of feedback, the TWSL can be operated over lasing threshold, giving higher gain per unit length than the simple SOA. So there are basically many types of optical amplifiers are available, like tapered amplifiers, optical parametric amplifiers, or but the main reason of using an optical amplifier is to uh, amplify the optical signal without converting it to electrical signal. That is, we can directly convert the optical signal. We can directly amplify the optical signal without converting into electrical signal, so that there is no loss or no loss of data or no much such complexity. So this is the brief presentation on optical amplifier. Hope you liked it. Thank you.